In this lesson, we're going to learn how to graph linear inequalities. But before we do, let's recall how to graph an equation. So remember that slope-intercept form of a line indicates that the value in front of the x variable is the slope, and the constant added to the end of the equation is the y-intercept. So if we want to graph a linear equation in this form, the first step is to turn it into slope-intercept form. So first of all, we can subtract 2x from both sides. And now when we divide by 3, we end up getting negative 2/3 as the coefficient of x, and divide 18 by 3 and we get 6. So notice that this indicates that 6 is the y-intercept, so we can plot the y-intercept on our graph. Now we plot the slope of negative 2/3, which means we simply go down 2 and right 3, because it means rise over run. Now we can continue to do that over and over from each point, down 2, right 3, down 2, right 3, and here is our line. Now let's take a look at what happens when we have an inequality. Now in order to graph an inequality, we're simply going to graph the corresponding linear equation, but we're going to make two modifications. The first thing that we're going to do is that sometimes the line will be solid, and sometimes the line will be dashed. Sometimes we're going to shade above the line, and sometimes we're going to shade below the line. So the first thing to recognize here is that after the inequalities in slope-intercept form, we're going to look for either a less than or equal to symbol or a greater than or equal to symbol. If we see this equal to symbol attached to the inequality, that means that anything on the line will work, and therefore we're going to draw a solid line, since the line is part of the solution set. But if we don't see an equal to sign attached to the inequality, that means that the line and any point on it can't be included in the problem set, or in the solution set, so we're going to draw a dashed line. Now in addition to that, we're going to look to determine whether or not it says less than or equal to, because that means that we're going to be shading below the line. So we often think of the line as a hill, and if we were to draw a hill on a piece of paper, we would be shading below or shading the hill. While if we're using a greater than or equal to symbol, that means we're going to be shading above the line. And so if you think of the line as a hill, that means we're going to be shading up towards the sky. Now one last thing to remember about inequalities that we'll see in the next problem is that if you multiply or divide by a negative number, we always have to flip the inequality sign. So let's take a look at this example. Here we have a less than symbol. That already indicates that when we draw our line, it's going to be a dashed line. We also need to make sure that we're putting this equation, or this inequality rather, in slope-intercept form. So the first thing we're going to do is subtract x to both sides. So now the negative x moved on to the right, and now we divide by negative 2. And notice in dividing by negative 2, we're dividing by a negative number. So that's going to switch this less than symbol to a greater than symbol. And now we divide negative 1 by negative 2 to get 1/2. And we divide negative 8 by negative 2 to get a positive 4. So we're going to start the graphing process just like graphing an equation. We're going to start with the y-intercept of 4. And now notice that the slope is 1/2. So we're going to rise 1 and run 2. Rise 1, run 2, and so on. Now before we graph the line, remember that this is a less or a greater than symbol, no equal sign, and therefore this is a dashed line, which means that any point that's on this line will not be part of my solution set. And now if we picture this as a hill on our paper, with a person walking on the top of this hill, then we're going to be shading the sky, since it says y is greater than 1/2 x plus 4. And that means that any point that's in this shaded region will be a solution to this inequality. Now another way to test test which direction to shade is to just pick a test point. In this case, the test point would be a good test point to choose is often 0, 0. So we just want to determine whether or not we should shade the direction with 0, 0 or not shade the direction with 0, 0. So we're going to plug in the values of 0 for x and 0 for y, and that gives me 0 minus 0 is less than negative 8. Well, that's false. 0 is not less than negative 8. So that means we are not shading the direction that includes 0, 0, which is why we shaded the opposite direction above the line. So whatever method makes more sense to you, that's the method you should use. Now what if we were to graph x minus 2y is greater than or equal to negative 8? Well, notice it's very similar to this inequality, except the inequality sign is switched now. So same idea, we subtract x, divide by negative 2, and notice that we again have to switch the inequality sign. So notice that we still get the same quantity on the right side, 1/2 x plus 4, but now the inequality sign is less than or equal to. So let's notice what that does. That means that we're first of all going to draw a solid line because it says equal to, and now we're going to be shading less than the line. Think of it as the hill, and we're going to be shading below the hill. So this is our solution set. But we could also use that other method where we pick a test point to determine the direction to shade. And therefore, if we choose 0, 0 and plug that 0, 0 into x and y again, right over here, then we would indicate that 0 is greater than or equal to negative 8. And that's true. 0 is larger than negative 8, which is why we're going to be shading the direction that includes 0, 0. So this shaded region is considered our solution set to this inequality. We now want to take it a step further here and recognize that sometimes we have to grab vertical lines or horizontal lines. Remember that vertical lines have the form of x equals a constant because we're saying that every x value at a particular x value is going to be true. So let's say we wanted to graph x equals 2. Well, that would indicate that we're going to go to the x value of 2 and put a vertical line wherever 2 is. But now, because we're graphing x is less than 2, we're still going to graph the vertical line, only it's now dashed, and we're going to be shading to the left for all the x values that are less than 2. If we want to graph the horizontal inequality, notice that we graph y is greater than or equal to negative 3 by first graphing y equals negative 3. Notice that that's the y value at negative 3, and therefore greater than or equal means we're going to be shading above.